Hello, community. Today we talk a new AI and we talk about continuous pre-training and a specific form here of policy optimization. But at first, I would like to answer all the questions that my viewer have. So 1 minute interrupt response to my viewer. Especially to these two topics here, pre-training, CPT, supervised fine-tuning. There was a question, and to quantum AI to my last video, there were one question and one topic, and it was, what is the value of this for my viewers? And one of my viewers said, hey, tell me in US dollars, how much is this now helping me? How much does it increase my value? Now, you have a question. I try to answer your question. I don't know what your value is, but let's say you know your value, no? Because maybe you are paid by your employer a certain amount of salary, you have a specific bonus, so you have an economic absolute metric that you can say, this is what I earn. Beautiful. So let's have this reference system for answering your question. And now let's say you are one of 1 million people that learn how to vibe code. Now let me ask you, how much does your value for your employer increase for your particular job? The only person who knows the answer is you. How much does your value increase for your employer, for your salary, if you learn MCP, Model Context Protocol, Client-Server Architecture, and you say, yes, I can set it up, and we know both, no? Gemini 2.5 Pro does this automatically for you, you just have to ask Gemini. But imagine you are one of 100,000 people who know how to do this. You know how much your value will increase. But just imagine you are one of 100 people who have some unique knowledge, some unique insight into the latest of AI research. What do you think? How much your value would improve if startup companies notice that you have this knowledge and they are now trying to hire you? Only you are the one to answer this particular question. But let's start the videos, and I would like to show you how easy it is, even if you just watch this video, to understand the latest AI. Because yesterday we have a new Japanese medical AI system published for the local market of Japan in Japanese, and I think it's great if regions now build their own native language model, and I would like to help this, support this. I think it's great, and I want to show you how easy it is to build AI if you understand some basic facts about it, and how we can even improve on this Japanese AI model, how we can understand the limitations, and the next step in the evolution of this. And of course, I'm not gonna talk about quantum, because you know what is the value? It is how to learn this, how to learn faster about AI, and how to build those systems. Because guess what? Companies currently can't find quantum AI experts, and they pay ridiculous amount of salaries. So let's open up this video and let's come here to the first point. We have a new LLM. You find it here on Hugging Face, Preferred Med LLM Q172B. And this is here a base model with a specific training. And the training is here on the Japanese medical domain for a local market, Japan here. And they have a secondary condition to achieve a high accuracy and some stable reasoning. Because they found out even if they turn down the temperature of their LLM, the reasoning traces are not consistent. And especially if you are in a medical or a clinical or hospital environment, you don't want that the LLM jumps around in its reasoning. You want a clear, proven reasoning trace. So, how they achieved this? What were the steps? It is so easy to explain. Stable reasoning they did here with a modified DPO. Yes, beautiful. But let's start. The first step is here, since they took here a general model, they had to add knowledge, instill deep domain knowledge of the Japanese medical market, so the Japanese medical data corpus. And what was the training methodology? Of course, continued pre-training. So, to add recent knowledge in a specific Japanese data structure, they did here CPT. Their base model was a Q1 2.5 72 base model, and I think this is the right size. 72B for medicine, this sounds about right. If you're not really wealthy, this is, yes, I would say that's the same thing I would do. Second step is they decided they want to have reliable reasoning pathways. So they decided to go here with a particular policy optimization here in reinforcement learning, and they went with RPO. I'll show you this in a second. It's rather easy. So you see here our DPO, and here, knowing this, you might ask, hey, this is interesting. Why they didn't use your RFT? Why they went here with the classical reinforcement learning with a DPO alternative? We'll have a look at this. So you see immediately, second step is here for stability of the reasoning pathways, of the knowledge, how the knowledge is presented now to the user of the AI system. Our little spark of genius, it is so easy. Why not supervised fine-tuning, you might ask, ne? Well, it is easy because if we look at the goal that they wanted to achieve, why they built the model, the AI system, they just wanted here the Japanese medical licensing examination. So I suppose this is here the last step before you become somehow an official doctor. You have to have a beautiful exam. So and they wanted to see how good is our AI system on this Japanese, very specific local market condition. So you see, it was not trained on a specific task, but it was update the general knowledge, become now a perfect medical AI system, maybe up to the latest knowledge, and then align the behavior of the model in a particular way for reasoning traces. But it was not that we had to do a single specific task for supervised fine-tuning. You see how easy sometimes explanations are? So how would I call this? I would call this a zero RL because, remember in this video I showed you, if we just go with a reinforcement learning and have no supervised fine-tuning before, so this means instead of supervised fine-tuning plus RL, we have zero, nothing, just RL. So we build about the pre-training, we have a continuous pre-training where we add the medical knowledge, and this is a zero RL model. Let's come to terminology. You see, here is official wording here, found a study published yesterday, a two-stage fine-tuning process. And you might say, hey, that's interesting, because if they do CPT, this is a pre-training. Why they say fine-tuning? And then if they go with reinforcement learning is not fine-tuning, It's a kind of its own. Well, different scientists feel different about the terminology. We just have to accept this. So a lot of people say, hey, training is the pre-trained model we get out of Google, of OpenAI. This is our trained model. And now whatever we do is post-training in general. Okay. Some people say, wait a minute, this is continuous pre-training. So it goes with the pre-training. So this here is the training. And whatever comes afterward is just the post-training. No, makes sense. Pre-training, post-training. Great. And here we have supervised fine-tuning, and then we have reinforcement fine-tuning. Yeah, and there's something like reinforcement learning, but never mind. Yeah? And then we have different scientists who say, hey, wait a minute. Since we have here inference scaling, and test time compute scaling, we just call this the training time compute, and there's everything in it. No pre-training, CPT, SFT, RFT, RL, GRPO, DRPO, TRPO. Okay, so we do not have a global agreement on the word. What does it mean here? A fine-tuning process, but they specify it, and this is beautiful. So easy, say, hey, CPT, beautiful, we know exactly where we are, and policy optimization, we know exactly where we are. Great. The rest is just semantic. No problem at all. Now the others tell us, hey, we propose and evaluate a two-stage CPT and RPO fine-tuning. Okay, no problem with me approach designed to instill deep domain knowledge, CPT, while addressing the critical issue of performance instability when LLMs generate reasoning explanation in specialized domain, and you do not want to have this in medical AI. Great. We have this model online. This is here on Hugging Face. Beautiful. You have it here in Japanese, and you see the download were only just 114. And that's a pity because I think we should have, if you want, for your language, you should have your model. And I know that OpenAI offers, 80 languages or whatever, but if you train it specific on your, let's say, national data set, maybe you have, I don't know, a special medicine. I know, for example, in China, they have a lot of plants and teas and herbs. And, and in Europe, we go high chemical, pharmaceutical products, So whatever is in your local market, it should respect your culture, what you are used to, what your, parents were used to. So I think it's great if you have multiple models that are really in the original language, respecting also the culture where they are. And they say, it's beautiful. And of course, they have to do the training. Yeah? And if they go here for continued pre-training, you can imagine it's not easy on the computer infrastructure. So they say we address this, our significant computational challenges, and we employ here a quantized lowering adaptation, QLoRa, and we combine it with a 4-bit quantization. Now, you know me that a year ago we had a video here where I explained QLoRa with a 4-bit quantization and even with a Colab notebook, so we could test it out and we could see the differences. Beautiful. And I'm not a fan in research for a 4-bit quantization. My absolute limit is 8-bit in research, but I would never go to 4-bit. But I understand if you have limitation and they used only 4 NVIDIA A100 80GB GPUs. I understand. It's simply how much you can afford in your computer infrastructure. But you know what? If you don't have the money, you can have the knowledge. Because if they would have seen here also a year ago, my video that QLoRa is not the best implementation. There are better ideas like LoftQ. Well, but this is another story. So I understand that I want with 4-bit, but if you're in research and you can somehow afford it, a 16-bit, a 16 NVIDIA A100 might be a better cluster to run this and have a better performance maybe, no? Okay, the next one, as I told you, a very special form of DPO, a reasoning RPO, and they did it for one particular reason. They wanted coherent reasoning traces and explanation. Now, there's a particular paper. This is more than a year old already. Here you see version 3 from June 2024. This is Meta, and they had reasoning preference optimization. Beautiful. And it is a rather simple system. Let's see how they build a specialized preference dataset for their RPO. The, if you want, schema is rather simple. They have here question, explanation, and an answer. And then, second, they generate responses automatically categorized whether the final answer matched to the ground truth, which means the correct answer. So they labeled the chosen responses here or incorrect final answer. And they had a third category, ground truth responses. So it's a simple data set that you applied and you train it. And if you want to know more about DPO, 1 year ago, I have here explaining here a detailed video, DPO optimization here. And then even if you want to go here into the test time compute, we went from DPO to TPO, test time preference optimization. Or if you want to do this combined here with a supervised fine-tuning DPO, we have OPPO. So there are so many videos available. You can choose the methodology that you like because you know that you have options. Now, let's come to the evaluation. And this is really interesting because they did 2 different things. A standard 3-shot setting where the prompt included 3 examples consisting of a question, the options, and the correct answer preceding here the target question, and then one with an explanation where we have this, provide a step-by-step explanation before delivering the final answer. Let's have a look at this. So, the study we're talking about was published here, 25th of April. So, stabilizing reasoning and medical LLMs 3 days ago with continued pre-training, beautiful, and a reasoning preference optimization. So you see, it's not a policy optimization, but a preference optimization as I learned right now. And you see, yes, those abbreviation, it is a problem. University of Tokyo, beautiful Japan, and this is done while these colleagues here were at a particular company also in Tokyo. Beautiful. I love it if you have this collaboration between industry and university. So let's have a look. They say they really highlight here this reasoning preference optimization for stabilizing here the reasoning generation for the medical AI, and they show the importance of optimizing here reliable explanation. And this is where they go for in medical AI. And this is just if you want a research model, but never mind. So here we have now the benchmark. And this, remember, for a Japanese model, and I love this. Unfortunately, I can't read the answer, I can't read the dataset, but never mind, I trust them. So let's have a look. So here we have this screenshot, and then we have this screenshot with explanation. And for this new model that they did train here, you see identical results. So great. If you go for their latest GPT-4 Omni, it was, almost the same, a little bit behind, but here a little bit better, so okay. And then you have all the different models, beautiful. And you see, for example, what I find interesting is for the instruct model and the base model, that they get here the same performance data. But if you say, hey, explain step by step, there is a difference. This is absolutely fascinating. So you see, you can have fun with AI. Now, what I love are studies when they say, okay, we want to understand what happens. We start with the base model. So we have a performance of 80%. Then we just add here this RPO. So we go from 80% to 83.8%. Great. But what if we just go here with the continuous pre-training? And you might say, wow, look at the continuous pre-training alone on the base model gives us a much better performance. So we see if we want to add knowledge for a general medical exam, then CPT seems to be the right step to go because we had 86.7%. If we then add a DPO, now this is really the classical DPO, we just increase here from 86.7 to 86.8. So not really. And then if we do now the new RPO, the preference optimization, then you see it's identical. So for me now trying to understand this, I see, okay, this is the base model 80%. And what gives me, for the simplest, fastest improvement, continuous pre-training. I just add knowledge. And I jump from 80% to 86.7%. Great. And the best thing I can achieve is 86.8%. So 0.1 percentage point, I say, okay, given that I don't have to pay for this, given I don't have to have the computer infrastructure for this, given that it is faster, I would say, great. So continuous pre-training, if you have a general exam, this might be the way to go for the Japanese model here. And then, of course, they decided, hey, let's go for other benchmark, of course, in Japanese. So you can see here all the data, and this is interesting because somehow this is strange. Have a look at this, take your time, and then you will understand what I mean. And you know, there's a simple explanation. Because if we look closer here at their performance test, they have clear limitations. So let's have a look at this. The first one explains here the strangeness, if you want, because they just want with multiple choice question answering benchmarks. So this means if we go for a consistent reasoning, we don't have the reasoning traces. So then if we just have, if you want a end reward feedback, an end reward factor coming from a multiple choice Q&A, of course, then this delicate reasoning, the performance improvement in the reasoning in a multiple choice, it's really hard to distill and find out. So, okay, now I understand. Multiple choice is their Japanese exam, great. But for the testing, it would have been much more interesting for me now here if they would not go with a multiple choice, but really have a deep look into the explanation of the models. Second, all the RPO data were semi-automatically generated. Well, yes, of course. Third, they did not investigate, as you have seen, RPO with instruction tuning. There was no supervised fine-tuning or anything like fine-tuning with this. Okay, they missed out on this. Yes, we noticed this. And then they said, our problem was computational resources. And I think they did the right thing. They went with a model that was bigger, 72 billion free trainable parameter. And they said, okay, we have to go with a Q-LoRa adapter. Absolutely fine with this. This is the right thing to do. But to go with a 4-bit quantization, this really hurts the performance. It is highly specific to the task, highly specific to the benchmark that you run. But I would have stayed at least at an 8-bit, but whatever. I understand their reasoning. And you know what? I had to smile. In the acknowledgement, they say, hey, from the University of Tokyo, we would like to thank here this company, that their team members, they supported here the infrastructure support. So this means the computer infrastructure. So this means the NVIDIA GPUs. And this is now, again, we are still there. My goodness, please, globally, all universities on this planet need better access to the compute infrastructure resources we need for AI. We can have the best students, PhD students, if they don't have access to AI infrastructure, to the clouds. We can't run our experiments. We can't improve on our knowledge if we are always limited that we don't have the compute resources that we need. This is not for Japan only. This is globally. Every single nation in this world has the same problem. And it would say, hey, but wait, there was a second point. No, what about this quantum AI? No, how to learn and build. And you're right. So, but since we're at the end of the video, let's make it fast. This here is Business Insider, April 27, 2025. And they say, there is now a talent shortage. We don't find the people, let's say here for quantum computing. And it's now that, if you read this article, they say quantum companies and startup companies are funding now programs and university courses to train new talent. And whatever a new industry branch like quantum computing is investing in new courses at the university because the university cannot afford to offer those quantum computing courses, you know that the companies need people, need talent, need experts in AI. And yes, of course, we have research published by international consulting companies, blah, blah, blah. And they say, yes, 75 companies want to integrate AI. But you know what? Of the people, only 35% received any AI training in the last year. Oh my goodness. So, the talent pool, they tell us, in the quantum industry, which is just a fraction of the size of the legacy AI field, is even smaller. But they say the demand is growing because this is the growth trajectory for the market development. And they say that the quantum computing is expecting to create an estimated 250,000 new jobs by 2030 and close to 1 million new jobs by 2035 plus. These are only projection. This is not scientific data, but you understand where they are willing to invest money. So, coming back here, the value of my videos. You see where we are going? Great. If you're interested to learn more, I think there are beautiful companies, and you see it everywhere. IBM, Microsoft, NVIDIA, Google. They say, hey, we're looking here for new talents. And they also say, hey, we have to combine computer science, mathematics, and quantum mechanics, at least quantum field theory maybe. And they say, yeah, we understand it remains deeply technical, and it is really expensive to advance here, and we need absolute experts who understand all of this. Sometimes it is not just people who know how to code or do vibe coding with AI. Maybe vibe coding is not the solution here. Hint. And I have to tell you, they are unbelievable great courses for you if you really want to have a deep dive. MIT, University of Chicago, University of California, Berkeley. They offer here some beautiful quantum computing courses. Some of them are even free. Okay, you don't get an official certificate from I don't know what company, but if you want to learn, the resources are out there. So don't wait, start today. Great. And you know what? What I really appreciate, here my last video on quantum AI, and I have to tell you, I had a low expectation how many people would watch this. But you know what? I had already 2,700 plus views just in the first 19 hours. So I just want to tell here my audience, hey, you are great. I highly appreciate this. And my goodness, almost 3,000 people here found it interesting to have at least a look at quantum AI framework systems because it always goes hand in hand. You have to have the right AI model, the software, the idea, the theory, the framework to have the perfect implementation then on quantum computing. So quantum AI and quantum computing, I think, are some absolutely fascinating topics if you want to have your professional career in the future. I hope you enjoyed it. Hey, why not subscribe? And I see you in my next video.